Hello everyone, myself Hans. Today we are going to solve the problem of UPSC Maths Optional Paper 1 question from topic Analytical Geometry. Here in the question, prove that the locus of the lines which intersect the three lines y minus z is equal to 1 and x is equal to 0 is the first line, and the second line is given by z minus x is equal to 1 and y is equal to 0, and the third line is given by x minus y is equal to 1 and z is equal to 0, and the locus is given by x square plus y square plus z square minus of 2yz and minus of 2zx minus of 2xy is equal to 1. We have to prove. First, let's solve the problem. Given lines are first line is given by y minus z is equal to 1 and x is equal to 0, and the second line is given by z minus of x is equal to 1 and y is equal to 0, and the third line is given by x minus of y is equal to 1 and z is equal to 0. The given line can be also written as, that is, y minus of z minus of 1 is equal to 0 and x is equal to 0. Let this equation 1. And the second line can be also written as, that is, z minus of x minus of 1 is equal to 0 and y is equal to 0. Let this equation 1, 2. And the third line can be also written as, that is, x minus of y minus of 1 is equal to 0 and z is equal to 0. Let this equation third. And further we have to write any intersecting line of equation 1 and 2, that is y minus of z minus of 1 and minus of k1x is equal to 0, and the second line is written as, that is, z minus of x minus of 1 and minus of k1y is equal to 0. This is the intersecting line of equation. Further, from here we have to let this equation 4, and we have to find the value of k1 from here, k1 and k2. From the first intersecting line we have to find the value of k1, that is k1x is equal to plus of y and minus of z, and plus of 1 minus of 1 is taken to right hand side, that is plus of 1 and plus of z and minus of y. And from here, that is, we have to find the value of k1, that is k1 is equal to minus of 1 plus of z minus of y upon x, and we can also write, that is k1 is equal to y minus of z and minus of 1 upon x, multiplying with the minus, that is minus 1 minus of z and plus of y. Further, from the intersecting line of equation 2, we have to find the value of k2. That is minus of k2y is equal to plus of z and minus of x, and minus of 1 is taken to right hand side, that is minus is taken to right hand side, that is plus of 1, and minus of x, that is plus of x, and plus of z, that is minus of z. And from here we have to calculate the value of k2, that is k2 is equal to minus of 1 plus of x minus of z upon y, and we can also write multiplying with the minus, that is plus of z and minus of x and minus of 1 upon y. We have to write the value of k1 and k2 here, that is the value of k1 is y minus of z and minus of 1 upon x, and the value of k2 is z minus of x minus of 1 is equal to upon y. Further, we have to solve. If the line third intersecting equation first and second, then we put the value of from equation 3 that is z is equal to 0 and x minus of y minus of 1 is equal to 0 can be written as x is equal to 1 plus of y. In the equation fourth, first we have to put the above intersecting equation, that is first we have to put, that is y in place of z we have to put 0, that is y minus of 0 and minus of 1 and minus of k1, and in place of x we have to put 1 plus of y, that is 1 plus of y is equal to 0, and from here that is y minus of 1 and minus of k1 and minus of k1 and minus of k1 y is equal to 0, and we have to take, that is, and we have to take y and k1 y in one bracket, that is taking y common, that is 1 minus of k1, and remaining minus of 1 and minus of k1 is taken into right hand side, that is plus of 1 and plus of k1, and from here that is y is equal to 1 plus of k1 upon 1 minus of k1. This is the value of y. Further we have to put the value z is equal to 0 and x is equal to 1 plus y in the second intersecting lines, that is in place of z we have to put 0 and in place of x we have to put 1 plus of y and minus of k2y, minus of k2y once again. In place of z we have to put 0 and in place of x we have to put 1 plus of y, and here is minus of y, here is minus of y, minus of 1 sorry, and minus of k2y is equal to 0, and from here that is minus of 1 and minus of y, and once again minus of 1 and minus of y, and here is minus of 1 is already present, and minus of k2y is equal to 0. From here that is minus of y and plus minus of k2y is taken to right hand side, that is minus 1 and minus 1, that is minus of 2, and minus y is taken into right hand side, that is plus of y, and minus of k2y is taken into right hand side, that is plus of k2y. From here we have to take common y, that is 1 plus of k2, and from here we have to find the value of y, that is y is equal to minus 2 upon 1 plus of k2. Let this is equation 5th and this is equation 6th. And from here equating equation 5 and 6, as we saw, if the left hand side are equal, then we have to already equal to the right hand side. If the left hand side are equal, then we have to equating the right hand side, that is equation 5 of right hand side is 1 plus of k1 upon 1 minus of k1 is equal to, and the equation 6 of right hand side is minus 2 upon 1 plus of k2, and from here we have to cross multiplication, that is cross multiplication with 1 plus of k2 and 1 plus of k1, that is first we have to 1 plus of k1 and further we have to multiply with k2, that is plus of k2 and plus of k1 k2, and from here that is cross multiplication with this, that is minus of 2 and plus of 2k1, and from here that is k1 and plus of k2 and plus of k1 k2, and here is plus of 1 and minus of 2 is taken into left hand side, that is plus of 2, and minus of 2k1 is also taken into minus of, here is minus of 2 minus of, we can also minus 2k1 into left hand side, that is equal to 0. Then the remaining is we can also write that is k1 and minus of k1. Here is minus of 2k1, that is minus of k1, and here is plus of k2 and plus of k1 k2, and here is 2 plus 1 is 3 is equal to 0, and let this is equation 7. Putting the value of k1 and k2 in equation 7, which I earlier find the value of k1 is this and k2 is that. We have to put here, that is the value of k1 is y minus of z minus of 1 upon x, plus the value of k2 is z minus of x minus of 1 upon y, and plus of y minus of z minus of 1 upon x into z minus of x minus of 1 upon y, and plus of 3 is equal to 0. Further we have to simplify. We have to taking LCM first, that is taking LCM, that is x xy xy. Here we have to take LCM xy, and from here there is x and there is no y, so we have to multiply it with x. One second. We have to multiply it with y, that is minus of y square and plus of, once again multiply with y, that is plus of yz and plus of y. On multiplying minus of y and plus of z and plus of 1, further we have to multiply with y, that is y square plus of y and plus of y. Further plus, here y is present, x is not present, so I have to multiply this term with x, that is plus of xz minus of x square and minus of x, and from here we have to multiply these terms, that is y minus z minus 1 and z minus x minus 1 with these terms, that is first we have to multiply with z. First we have to multiply with z, that is yz minus of z square and minus of z. Further we have to multiply minus x with y minus z minus 1, that is minus of xy and plus of xz and plus of x. Further we have to multiply minus 1 with this bracket, that is minus of y and plus of z and plus of 1. And here the xy is not present, so I have to multiply 3 with xy, that is plus of 3xy is equal to 0. Further we have to simplify, and xy is cross multiplication with 0, so we have to get 0. Further we have to simplify, that is minus of x square and minus of y square and minus of z square, and we have to eliminate some terms, that is plus of yz and plus of yz, once again plus of yz and plus of yz. Here is plus of 2yz and plus of y and minus of y is cancel out, and minus of x and plus of x is also cancel out, and the remaining is, one second, minus of z and plus of z is also cancel out, and the remaining is, one second, xz and xz plus of 2xz plus of 2xz plus of 2xz, and further we have to minus of xy and plus of 3xy, that is plus of 2xy and plus of 1 is equal to 0, and from here we have to multiply minus with both the side, that is x square plus of y square plus of z square minus of 2yz minus of 2xz and minus of 2xy and minus of 1 is equal to 0, and further we have to write, that is x square plus of y square plus of z square minus of 2yz minus of 2xz minus of 2xy is equal to 1. This is the required locus of the given problem, and the locus is given by x square plus y square plus z square, that is x square plus y square plus z square minus of 2yz and minus of zx and minus of 2xy is equal to 1. This is the required solution of the given problem. Thank you class, and thank you for watching.